Malware analysis is usually broken into two categories. There's static analysis and there's dynamic analysis. In static analysis, we might have some file, let's say this one here or this one here, and without executing it, we are going to analyze it, hence statically. On the other hand, dynamic analysis is the analysis you do when you're actually running the file. Generally speaking, dynamic analysis allows you to see much more about the file or process you're studying, but it also requires you to actually run it, which can be problematic. If you're running malware, that means you need to be doing it in a safe environment. You might have to clean up the device after you ran it. And there's also the possibility that it won't execute in the environment in which you're studying the sample. Static analysis, on the other hand, is environment independent, doesn't contaminate the environment, but can also reveal much less, especially considering that a lot of the processes and samples out there will be packed. That is, they are obfuscated in a certain way that makes it difficult to peer into the file. So let's take a look at basic static analysis. So I have a few tools here to demonstrate. One tool I have is called strings. Basically, the way you use strings is you run it against some file, and then you might want to log the output, and it's going to collect all the embedded strings. Then we're going to take a look, and we see that it's collected all sorts of strings. Some of them are nonsensical, some of them are plain English, and some will turn out to be either functions or important information. Now let's run it against a malware sample. Again, we have a lot of nonsense. Towards the end, we might see some indicative strings of what this sample is. However, if the file was packed, all of our strings may have been nonsense. So this technique only works some of the time, but it can be very helpful. Another tool at our disposal for static analysis is called PE Studio. Basically, it's going to analyze all sorts of things, including the PE header and libraries, and we're going to discuss PEs in more detail in future lecture. It's going to take a bit of time, and then it's going to output all sorts of information, such as the size of the DOS stub, the header, information about directories, entropies, and so on. And we can take all this information and study it and determine what exactly the sample is doing. Now let's try to do some dynamic analysis. So I have here process monitor, procmon, as it's usually known. And as soon as I opened it, it captured all sorts of information. It's capturing registry key changes, capturing file changes, and from all sorts of services and processes. I will have to filter out a lot of information. Now let's run the sample and see what kind of information procmon captures. So I'm going to filter out all the rest of the stuff. Okay, and I see files are being opened and closed. Registries are being changed. There's a lot of writing. And of course, if I actually look at my desktop, I can see that it's a ransomware that's encrypting the device. In general, it's less obvious what exactly a sample is doing. It might be secretly logging your keystrokes, or changing permissions to files, or doing other secretive operations. For that reason, dynamic analysis can help you see what's happening.